I started recording. Let's go to the board. I'll do like a five-minute review. When I say 5-minute review, it's usually that means 10-minute review. Okay, I'll say 5-minute review. Let's do a quick review. Maybe I'll do oral review. Let me hope to close the window. I think it's going to be causing a lot of glare. Okay. So my pens are here. Missing one pen. That's going to be this one. Let's write it in blue. Chem8. Tuesday, Thursday, fall 20, 11, 17, 2020. Okay. I'm going to drop my pen. And there is a mirror right here, okay? There is a molecule here, and there is a molecule here. They are mirror images, and let's say they're superimposable. Let's say they're superimposable. Should we call them, give them any special name? If they are mirror image and they're superimposable, not like my hands. If they're superimposable, what do we call them? Hurry up. Somebody please talk to me. Please talk to me, I'm lonely. Well, I have been perceived as a condescending human being instructor by some of my students in my lab, organic lab. I just shot them an announcement that I'm going to slow down, back off, maybe because I asked them to answer. I hope nobody from this class is going to go to our chair and complain about me. Somebody did that actually. Anyway, so if there are two objects, let's say two objects such as this, right? This is the main object, this is the mirror image. If they superimpose perfectly, if we could put one inside another and they look exactly like the other guy, what do we call them? Do we call them any fancy name, or do we just call them their what? Please respond. Superimposable mirror image. What do we call them? You guys will be taking the quiz in like a few minutes, less than an hour.
Is it an enantiomer?
They're mirror image and they're same, identical. They're superimposable. I'm not using the word non-superimposable. They're identical. They're not like my hands, which are not superimposable. I'm using a different scenario, a different example where the object and the mirror image are superimposable.
Is it stereoisomer?
You're making things complicated. Simplify life. When they're identical, they are mirror image and superimposable. They're identical, they're same. Just use the word same.
Is it chiral?
When they're not chiral, when they're mirror image and superimposable. Superimposable means they're identical.
It starts with an M, but I don't know how to pronounce it.
There is a word called meso. I didn't teach you guys that. Don't even dare to go there. Keep things simple. Let's blame it on the pandemic and learn a little bit less. It's not going to hurt your, in your future career development. I mean, if it were, I'm not underestimating you guys, but for Chem8, those of you guys are not like, this is not your major. So you don't really have to freak out about it. Okay. If they are mirror image and if they're superimposable, they're not enantiomers.
They're the same.
They stereoisomers?
They're not stereoisomers. They are same. Stereoisomer, the word comes when there is a problem in superimposing. Okay, I'm glad that we had this discussion. I should have had this discussion with my Monday, Wednesday, Friday class. Now I'm feeling guilty. If they're two identical objects, okay, if they're two identical objects, let me see. Do I have identical cups? I don't have any. I'm trying to look for something that are identical. How about, oh man, this is, sure, this might work. Ignore the color here, okay? Just, these are very similar. Pretend that they're identical, right? Let's say they're identical. I'm going to hold it far away from the camera so that it looks identical. Let's say they're two safety glasses. I don't know who uses the safety glasses and how I ended up having it in my office. I have no idea. Wait, one says Nemesis, the other one doesn't say Nemesis, okay? Pretend they're identical, okay? I don't really have anything else that are identical. Yeah, sure, I have two identical things here. Didn't work. Ignore this part. There are two identical spherical objects. They're identical, right? They're identical. There is no difference between them. Ignore this thing sticking out. I can only use my teeth to pull it out, but I'm not going to do that in front of you. I can't pull it out. Never mind. So imagine there are two little spheres, okay? Two little spheres, and they're identical. So if you hold one in front of the mirror, it will look like the other object, and they're identical. They're superimposable. When they're superimposable, the word stereoisomer doesn't come in play. Stereoisomer happens when there is a problem with symmetry. This is extremely symmetrical. There's a symmetrical plane cutting through here, left side and right side, same. If you turn the molecule, there is another plane, there is another plane, there is another plane. It's got infinite amount of symmetry. This particular ball, this particular sphere, right? This little thermocol styrofoam thingy, okay, model. It's supposed to represent a hydrogen or some atom. So because there is a lot of symmetry, this guy and its mirror image will always be superimposable. Keep it simple. Don't think too much. You guys are making things unnecessarily complex. When they're mirror image and superimposable, they're same. They're same objects. Nothing to be excited about, nothing to talk about, nothing to write a book chapter in organic chemistry book about. Okay, there is nothing to do with stereochemistry. Stereochemistry, that word comes in place like stereophonic sound. I remember I told you in the very first class, violin, viola, bass, maybe piano, cello, they're all here, right? And when you are, that means there is no symmetry, okay? If you are listening to the musical concert using a mono system, not stereophonic system, then all the sound will come from everywhere. A mixture of cello and piano and viola and violin and bass, that mixed sound will appear to your ear as if it's coming from here, from here, from here, from everywhere. Symmetric sound. No lack of symmetry, okay? Not dissymmetric or asymmetric. When you hear that concert, which was recorded in stereo system, and when you are playing it in a stereo, you will get a feel that some sound is coming from here because you have a speaker here and a speaker here. When you spend a lot of money, which people do, they have speakers up there, speakers in the back. You know, when an airplane takes off, it sounds like the airplane is literally taking off and going along the runway, which is starts from there and, you know, takes off from the back, right? So you get a stereo sound. That means lack of symmetry sound, because the airplane is taking off from there, the horse is galloping on the left side, and there is a man in the front, you know, kind of like playing with his belt buckle, which is touching the, I'm thinking about an old Indian movie, pretty cool, okay? If there is an Indian student in the audience, you might know what I'm talking about. Something like that. So lack of symmetry equals to stereo. The word stereo doesn't come when it's symmetric. This is too symmetric, right? So when you have two objects, lefty and righty, and they're superimposable, that means there is nothing to be excited about. It's extremely boring for me. I love stereochemistry. Okay, when they're identical, you put one in the other somehow. Maybe you can draw it in 3D using a CAD, computer-aided design, and put the other one inside the previous one, left one into the right one. They look identical. There's nothing to be excited about. Extremely boring topic, extremely boring objects because it's extremely symmetric. I like lack of symmetry. Okay, like the headlights of a motorcycle or a car, identical, right? They're mirror images. Nothing to be excited about. The first, let's not talk about it. I don't want to make myself more sad talking about my favorite thing, which is a motorcycle. Okay. Two objects, mirror image, superimposable, very boring. No stereo, no stereos, no enantiomer. The excitement starts happening when the lefty and the righty, the mirror images, are not superimposable. That's when you kind of start stretching up and sit up straight and like start paying attention, okay? They are called what? Non-superimposable mirror image. I know some of you were excited to spit that word out, but not until I say non-superimposable. That's the only time when you spit out that word. Non-superimposable mirror image. They're not superimposable. They're different, but they're mirror image. That means there is a problem with symmetry. The right side of my hand and the left side of my hand, they're not same. There is a problem. There is no symmetry. That's not like that. That's not like this. This is short and stubby. This is thin and short. This is in the middle. It's even my middle finger is not
It's
symmetric.
probably like now everyone comes to class today. No one's there ever.
Non-superimposable mirror image. What are they called?
Enantiomers.
Enantiomers. Very good. 1:25, important. 1:25 p.m., okay? So in order for a molecule to have this property, right? In order for this guy to be non-superimposable on that one, what kind of carbon has to be there in this molecule, and what should be the property of that specific carbon? Can it be a flat carbon, like an sp2 carbon, or can it be a cylindrical thing, like an sp carbon, or it has to be sp3?
sp3.
What's the shape around? I shouldn't give away the quiz. Do you guys deserve a little reward, like, you know, a little break? Okay, all right, I'll tell you.
Yes.
What's the shape of an sp3 carbon? It's
Tetrahedral.
tetrahedral. Sometimes it's perfect, sometimes it's screwed up tetrahedral, right? And what kind of property must that sp3 carbon have? Can it have 3 hydrogens and a methyl, or can it have 2 CH3s and 2 hydrogens? Will it suffice the requirement?
4 different groups.
4 different groups.
What is that carbon called?
Chiral.
Chiral.
All right, you passed so far. So the first 3 questions, you should get full points. There's no half point. Substitution nucleophilic. I'm not going to write anything down. This is an oral quiz. Like I had to take this sort of quizzes in elementary school. The teacher will bring you up to the front. You look like a complete idiot. I used to hate those moments. And I remember the geography teacher. This is the first time I got a 0. And my parents thought their world was coming to an end. Like I was definitely given to them as a wrong child in the hospital. My mom, when she would get pissed off, she would often say that I was the wrong child given to their family. The rest of the family was very decent. I was not. So this teacher asked, the deal was 10 questions, 10 points. The total point was 10. He asks you the first question. If you get it wrong, you get 0. If you get the first question right, the second question comes. Second question right, third question comes. So I got 0 because I couldn't answer the first question. I was nervous or I didn't study or whatever. Okay. SN1, what does it stand for? What does S stand for? What does N stand for? What does 1 stand for? A stands for Shantanu, N stands for none, 1 stands for make me one with everything. I'm just kidding. What does S stand for? Come on, guys, let's get serious.
Substitution.
S stands for
Substitution.
substitution. N stands for
Nucleophilic.
nucleophilic, not nuclear. 1 stands for
Molecule.
almost. One and a 3-letter suffix to
Unimolecular.
unimolecular. Okay, what else can I ask you? How many steps is SN1? 1 or 2?
2.
2 steps.
How many steps is SN2?
1.
1 step.
How does the nucleophile attack in SN1? Think before you give me a wrong answer. I'm going to be really mad. I'm going to smash the camera. The camera has been behaving surprisingly well. Well, the board is out of focus. Anyway, okay. What did I ask? How does the nucleophile come in SN1? Back, front and back.
Front and back.
Front.
What else can I ask you? Between, if you have an alkyl, let me make it difficult for you. If you have an alkyl chloride and an alkyl bromide, which of them will go faster, the bromide or the chloride?
Bromide.
Bromide.
Why? Is that just your imagination?
It's bigger, so
Bigger.
it's easier to kick out.
My ego? Which one is easier to kick out? Bigger ego or smaller ego?
Bigger.
Okay. What forms in SN1 that doesn't, it's a very bad question. Something happens in SN1 that doesn't happen in SN2. What's that? The C word.
Carbocation.
Okay. What else can I ask you? Help me. I think we have pretty much covered everything. What's that carbocation called? It's an I word. The dip. Reno, Donner Pass, dip, up, Fresno. What is the dip called? It's an I word.
Intermediate.
Intermediate. Yes, intermediate. That's the meal between 2 big meals, which happens all the time. Not equally spaced between 2 meals. I think we're done with reviewing. Anything else that I missed? Does the concentration of nucleophile, does nucleophile matter in determining the speed in SN2?
Yes.
Mhm.
How about SN1?
No.
No.
You guys, everybody is following? I know that some of you do not have your cameras on. I hope everyone is following. What else? I think that's it. That's all we have covered. Alkyl halide. Can you name an alkyl halide? How about this alkyl halide? How about this guy? How about, let's draw a funny molecule. I don't know where I'm going to put the halogen. That's a seahorse. That's wearing a slipper. That looks like a seahorse, right? What is that? What is that thing called? Name it. Name it. It's pretty easy. Come on, guys, hurry up. It's called interrogative halogen, halo interrogation. That could be a new technique for the Fresno PD. We are doing hello interrogation. We start with the hello. Hello, are you the thief? What is it? Come on, hurry up, quick, quick. Count the longest chain. Name the longest chain. Find the branch. Name the branch. Number the chain and put it in the right place. Something, something, something hyphen, something else.
2-chloroheptane.
Vincent is right. Next question. I didn't even think about the question, and looking at the hello interrogation sign, I'm beginning to get an idea. Can you predict what I'm thinking? Can you read my mind? Let me see if you can, if you have a future as an astrologer. In India, people believe in astrology. I don't. Do you know what I'm going to ask? What am I going to ask you? If you can give me that answer, I'll add half points to your total at the end of the day. And not at the end of the day, end of the semester. Read my mind.
You're gonna ask if there's a chiral carbon.
Oh man, what's your name? Darn it. Trinity. Trinity, send me an email because I really want to give you half point. You read my mind. You have a bright future as an astrologer. You can open up like, like, what is that called? We can read your palm, tell your future.
A psychic.
A psychic, there you go, psychic. You have a very bright future, Trinity. Which carbon is chiral, or if there is any chiral carbon? Is there a chiral carbon? 1, 2, 3, 4, 5, 6, 7. Is 1 chiral? 3 hydrogens. 3 hydrogens, 2 hydrogens symmetric, 2 hydrogens symmetric, 2, 2. What is the carbon number 2 attached to? It's attached to this. It's attached to that. It's attached to whatever this is. And it's also attached to something that's not shown here. What is that something?
Hydrogen.
The way it's drawn with flat lines, like solid lines, you can't tell whether it's R or S, but it's possible, right? In that case, we would have to draw it. That would be 1. Let's practice. The left one, is it R or is it S? How do you do it? That's a chiral carbon, right? That's a chiral carbon, so it's attached to 4 different things. Assign them their priority numbers. 1, 2, 3, 4. We don't like 1, 2, 3, 4. We want to make things more, exciting. Extra small, large, medium, and small. What is extra small?
The hydrogen.
Who is large? Don't give me a wrong answer. Think. So that's one thing. That's another thing, and that's another thing. Chlorine, methyl, and 1, 2, 3, 4, 5. Pentyl. So you have a methyl, you have a chloro, and you have a pentyl group. And you have a hydrogen. So hydrogen is extra small. So what should these 3 guys be? Which one should be large, medium, and small? atomic number first, and then you consider other things. So, answer. Excuse me. I don't have COVID-19. I hope. Every time I cough, I look around like, are people watching me? Okay. Between methyl, this big guy, hydrocarbon chain, and chlorine, which one looks the largest as far as atomic number is concerned? Come on, it shouldn't take so long. Hurry up. I still have to teach you guys something.
The pentyl?
Pentyl.
That's one group. One, two, three, four, five. That's another group. This is one group, and this is chlorine. The first station, first stop going from the chiral carbon, that's hydrogen. You know that's the smallest, extra small. Okay? When you go in the other three directions, the first stop is carbon, first stop is carbon, first stop is chlorine. So between two carbons and a chlorine, which one wins? Biggest atomic number.
Chlorine.
Not chlorine.
Large. Atomic number wins. Then you go to the next two. This guy and this guy, one is large, one is medium, and one is small. Okay. Now you go and see what else is attached to that carbon. Well, in this case, 3 hydrogens. In this case, 2 hydrogens and a carbon. Medium, small. Small, medium. So large, medium, small. Large, medium, small. What direction is that? Clockwise or anti-clockwise? This direction.
Clockwise.
Clockwise. So
Clockwise.
this guy is R. This is just the opposite. You don't have to go through that pain of spinning your hand in air and people thinking that you have lost your mind. If you start doing that when you're walking through your parking lot because you're practicing for the quiz, you're going like this, you'll be like considered stamped as an insane person. So it's opposite. So it's definitely going to be S because it's the opposite. I think review is done. Make sense? That should get you full points for the quiz number, whatever, 3. I'm not going to take a picture of this right now. It's also kind of confusing on the board, but you guys know what we're talking about. Okay, makes sense? Any questions? I'll pause for maybe 15 seconds. 15 seconds could save you 15 years of something. Okay. Let's move. Let's move to the next topic of our discussion, aromatic chemistry. In case I'm completely carried away and forget that there is supposed to be an exam starting at 1:25, just remind me, okay? I'm going to also make the quiz, publish the quiz. So let's talk about a completely new class of molecules, aromatic molecules, okay? We just started discussing that in my other class, in our Monday, Wednesday, Friday class. Since we are starting a new topic, let's clean up the board a little bit better.
She said they were generic.
Sorry? Was it for me? No. That's okay. I mean, I actually like people talking. So if you're keeping your camera on, if you're talking to someone accidentally, it's not a big deal at all. Board is focused. Well, we can tell right now. Okay, so aromatic compounds. Usually I spend a lot of time kind of like setting the stage, giving you like a background of aromatic compounds and how the first aromatic compound was invented by I believe a German chemist many years ago. His name is Kekule, but I'm not going to do that. The time is critical. I don't want to pack too much material, but I want to kind of remove the fluff as much as possible. Aromatic chemistry are molecules. Okay. What property do aromatic compounds have? Aromatic. What special property they have that you can answer without having much information on aromatic molecules? What is it? How many of you are here? Is this it? I mean, only 33. How come there are 33 people? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 25. Oh, there is a second page. Ooh. We should have quiz every day so that I see more people. That makes me feel important. What property does aromatic compound have?
Something involving smell.
Good, bad, ugly? Aroma means what? Bad smell or good smell?
Good.
Good smell, but you shouldn't be sniffing an aromatic compound, okay? Because most of the times an aromatic compound is probably pretty bad for you. Even though ibuprofen has an aromatic scaffold in the middle. It's really weird. We'll discuss that a little bit in the future because it's really funny how nature works. If you have an aromatic compound, the benzene, 6-member ring with 3 double bonds, you probably know the structure. Benzene has been known to public human beings for a long time. That's dangerous. It causes cancer. That's the first aromatic compound we're going to be discussing. So usually I don't drop the name benzene until like we go through aromatic discussion for at least for a class, entire class period. But this is different. This is special time with special needs, as wise people say. This is very special time with special needs. I mean, I always have special needs. Okay, so so my life has been a pandemic. You can joke about that. What was I talking about? Yeah, so you can have a benzene ring, 6-member hexagon, extremely dangerous compound. It causes cancer. You put a methyl group on that benzene from one of the corners. It's called toluene. It's not that dangerous anymore. Okay, that's fascinating. That's biochemistry. That's biochemistry, and that's also medicinal chemistry. Like, how does body process benzene, and how does body process methylbenzene or toluene? They're completely different. One of them can be spit out, modified and spit out. Other one cannot be spit out by the guard proteins. That's the problem. That's why benzene is dangerous and toluene is not. So the secret is out. Benzene is going to be our first aromatic molecule, okay? Yes, the aromatic compounds have aroma. Number one, if you really want to sniff molecules, that's probably a bad statement. I don't want to get fired. I'm already in trouble. You should sniff esters. Esters are pretty safe. Okay, we'll talk about it, like banana oil, other esters. They're pretty safe. I don't think this guy has an ester. Acetaminophen has an amide. Aspirin has an ester bond. We will discuss that at the last few classes. Okay, so let me finish this discussion as soon as we can, so then we can discuss the carbonyl chemistry. It's pretty fascinating, pretty cool chemistry. They got some aroma and they got some other properties. We're going to write that down later on. So maybe I should just have the word aromatic compounds here. Aromatic compounds. Okay. One of the properties is aroma. It's a strong smell, okay? And usually it's better to not sniff or get that smell inside your body. Smell means there are tiny particles of the compound, they're volatile, right? If you smell a compound more when they're far away from you sitting on a table in a vial or in a jar or something, that means they're more volatile. Volatile means they go directly into the vapor phase. Okay, they're up in the air, floating in air. Because we have air, it's kind of suspended. More smell you get, from a compound, that means more volatile it is. Okay, if you don't smell it, that means it's not very volatile. It's staying put wherever it is, in a vial, in a jar, in a brown bottom flask, in a cardboard box, in a plastic container, whatever it is. Okay, so when you smell something, at this time in my life, I can tell the difference between the smell of an aromatic compound and the smell of an ester. So I'm pretty cautious. But then you are smelling it, that means there are tiny particles that are actually getting into your nose and interacting with your smell receptors. And the smell receptor is sending a signal to your brain, and your brain is processing it as good smell, bad smell, pungent smell, annoying smell, terrible smell, things like that. Okay, that means smelling something means you have the source of that chemical inside your body, probably in your mouth, in your nose, in your ears, everywhere else. Okay, on your skin, if you have a cut, it's there. So that's why when you smell something bad, you are getting a very small dose of that compound. It could be dangerous. If you smell enough, it could create an impact in your living system. Okay, 110. So the way I'm going to set the stage today is by drawing a line that will show the energy. So let's do that, because if I just speak about it, it makes no sense. So anything that I draw higher up on the board has more energy. And the discovery of benzene happened in a way, it took scientists and chemists a long time to figure out that benzene has that hexagonal shape with alternating double bonds and 6 carbons and 6 hydrogens attached to itself. It's kind of like an alkene, but it's not an alkene. Benzene is falling under aromatic compounds, and every organic chemistry textbook has dedicated 1 or 2 or 3 chapters for aromatic compounds and their structure, aromatic compounds and their reactions, aromatic compounds in, I don't know, living systems. You can stretch it as long as you want. So they're just like alkene, but they're special. Why they're special? That's what I'm going to tell you about today as much as I can, and then we're going to continue discussing it on Thursday. And then on Monday and Tuesday, we're going to talk about something else, okay, before Thanksgiving. So if I draw something high up, that means high energy. If I draw something down below, that's less energy. Down below here, much less energy. So since benzene has 6 carbons, it's a hexagonal shape. 1, 2, 3, 4, 5, 6. Let's start with a 6 carbon species that has the least amount of energy. What's the 6 carbon species that's very flippy, floppy, and very flexible? You have studied it some time ago when we completed discussing electronic configurations and stereochemistry and stuff like that. Not stereochemistry, electronic configuration and hybridization and all that stuff. We talked about this group of compounds under hydrocarbons, and the 6 carbon chain guy is called something. What am I talking about? 1, 2, 3, 4, 5, 6. What is it? Stumbling? I couldn't hear you. Unmute.
Hexane.
Hexane, right, hexane. So hexane.
The screen is blurry.
Oh, okay. Thank you. Yeah, it is very blurry. Okay, let's hope for the best. Okay. So hexane has very little energy. So I'm going to draw hexane down below. Okay. This is hexane. Okay. If I put a double bond in hexane, it's going to go up in energy. Okay. What would be the name of this this alkene? Practice for your final.
Hexene.
Sorry?
Hexene.
Hexene. That's not it. You're missing something. Location, location, location.
What 1 hexene?
Okay. That goes up in energy, right? It goes up in energy by whatever. Let's say that energy, the amount of energy is, let's say, delta E. Delta E means a small piece of chunk of energy. Small energy means delta. Delta is small, right? Long time ago, I did calculus and differential calculus and equations. Delta means small. I forgot most of it. So if you put a second double bond, okay, it's going to be named something. I'm not going to practice that. It's called diene. It's hexadiene. Let's not worry about it. The bottom line is that energy gap between that guy and this guy is going to be delta E. It goes up as you increase the number of unsaturation. Unsaturation means double bond or triple bond. When you put the second double bond, the energy goes up by pretty much the same amount. Maybe not exactly the same amount, but very similar amount. Goes up by that much. Delta E from here to here, delta E from here to here. What happens when you put like a third double bond?
The camera is blurry again.
Okay, it must be the time of the day. Let's blame it on that. Oh man, I don't know how long I have to do this circus. Okay. Maybe it doesn't like me in the corner of the board. Something is wrong with this apparently smart camera. Logitech or Logitech. So if I stick a third double bond, let me know if it is out of focus again. Maybe once I move to the center, it'll become better. Let's put a third double bond. Okay. Again, it has been found that maybe not exactly same, but this gap of energy going from here to here, here to here, and here to here, as you increase the number of as you increase the number of double bonds by one more, the energy goes up incrementally by approximately the same amount. Nothing unusually, alarmingly weird. Okay. roughly delta E, approximately delta E. Okay, no drama, no unpleasant surprise, no pleasant surprise. So everything is good. Like no need to freak out. The chemistry, the world of chemistry, everybody is like calm and quiet and smoking those days and cigar and whatever, gambling and drinking. I'm painting a really bad picture of us chemists. Probably not that bad. That's the case. Now, when you have a cyclic system, when you are messing with hexane and adding double bonds, that's the way it goes. But what happens when you have a cyclic molecule and you're increasing the number of double bonds? Something very weird happens when you put the third double bond. Let's play with that. So let's start with cyclohexane. Cyclohexane. What does it look like in 3D? Who remembers? For final, what does cyclohexane look like in 3D? Is it a flat planar molecule? Cyclopropane, cyclobutane, cyclopentane, cyclohexane. The molecule can flip up and down and up. It looks like something.
The chair.
I'm not going to show you a chair when you're taking the final, so you better be prepared. Okay, cyclohexane, chair, but then this is cyclohexane. Put whatever energy this is higher energy than hexane. Cyclo means it has less degrees of freedom. It can't do this. It can't go crazy. Like it can't do a break dance like hexane can do. You don't know what break dance is. So it's got a little higher energy than hexane. Let's take a double bond. Let's use the same color coding. Okay. Cyclohexene. Okay, the energy gap, let's call it not delta E, but let's call it delta E1. Because I want it to be different than that number. Delta E and delta E1. One double bond. Let's put a second double bond. Oh, it's getting really exciting. A red and a blue. Okay. Energy gap. Pretty much the same. Delta E1, same amount. One double bond in cyclohexane goes up by so much energy. Second double bond in cyclohexene goes up by pretty much the same energy. Put the third double bond, something goes really messed up. It's not predictable. So you predict, this guy is actually called 1,3 cyclo. That's not cyclo, that's cyclohexadiene. Not going to be asked in the final or in the exam number 3. It's not. I'm just writing it because it sounds pretty cool. Cyclohexadiene. Not, you don't have to study it. If I put like a third double bond, okay, something unusual happens. Okay, you are supposed to call it cyclohexatriene 135. It should be called 135 cyclohexatriene. Okay, but that's not what it's called. That's the wrong name. And if I expect the energy gap to be delta E1, this is expected. This is calculated, theoretical. If you're doing calculations and you're trying to be a smart chemist and you say, oh, in hexane, when you put a double bond, it goes up by so much. Second double bond goes up by the same amount. Third double bond goes up by the same amount. Delta E, delta E, delta E. Over here, you are trying to use your existing knowledge and you're applying it to a different scenario, different system. In cyclohexane, put a first double bond, delta E1. Second double bond, delta E1. Third double bond, delta E1. Wrong. Theory and practical data, they differ. So in reality, this is wrong. Wrong in reality. Okay, it's supposed to be high up here. In reality, let me see if you guys can guess, like a wild guess. In reality, is this energy gap less than delta E1, or you think it's more than delta E1? Do you think this molecule is more unstable up or more stable with less energy? What do you guys think? Make a wild guess, right or wrong, who cares? Do you think it's actually higher up, more energy, or it's actually lower down, less energy than expected? What do you guys think? This is going to be a wild guess. You have no idea unless you have read the book. Any thoughts?
Higher energy.
Higher energy. So that's okay. It's supposed to be a wild guess.
Lower.
Lower, Trevor. This is Trevor. T as in Trevor. Yeah. Trevor says lower, and I missed your name in the past. This font size is so small for my old eyes. Okay. Real life. Third comment, high or low? The real energy of the tricyclic triene, whatever this is. It's called benzene, you know that. That's benzene. So that's why this is the wrong name. The real energy of benzene is less or more than expected. Anybody else? A third comment?
Less.
Less? It is less. So the delta E here is actually not up here, it's actually less. So the real molecule is down here. If I have to draw it, this is not the right level. The right level is down below. It's slightly lower. Okay, I need to keep an eye on the clock.
Yeah, it's 25 almost.
It's almost 25?
Yep.
24, yeah. So it's actually less, and that gap is called aromatic stability. I will take a picture and I'll make this video available, okay? Before you guys hang up, just let me make sure that I open the Canvas thing, okay? Let me just go to the front camera, go to Canvas, and publish. Good luck. I'm going to hang up.